Okay, welcome to the lesson on composition of functions. So a composition of a function is when you have a function that is the input for the other function. This symbol, the O, is not multiplication. It's of, h of n. This can also be written as h of n. That way, those two are equivalent. H. For this problem 10, h of g of t looks like h of g of t. That is very different than saying g of h of t, where h of t would be the input for g of t. So it does matter what the input is, which direction you're going. So this is a function of the same function, back to 9. How you rewrite it is you simply take h of n and you input it into itself, wherever n is. So I have n squared plus 2. That is going to be input into wherever n is. So I'm going to leave my space for where n is, n squared, and I'm going to add 2. So I take this quantity, which is h of n, and put it into the same function. And I have n squared plus 2, input for n, squared plus 2. I basically finish off the equation with just the inputs, no different than inputting a value and evaluating it. So now I have this piece that has to be simplified. To square this, I can expand it and then use FOIL to come up with the standard form or expanded form of this, which would be first is going to be n to the 4th, n squared times n squared, plus 2n squared, plus another 2n squared, that's the outside and inside products, for a total of 4n squared. The product of the last terms, 2 times 2 is 4, and then add 2. And then simplify, n to the 4th plus 4n squared, 4 plus 2 is 6. That is h of n. For problem 10, I'm going to take you to, through the first step, and then I'm going to ask you guys to finish it. H times t plus 5, that's h of t. T squared subtract t, that's g of t. So the input, we're inputting g of t into h. So put parentheses around g of t, put that in for t in function h. And I should have 4 parentheses t squared, subtract t, close parentheses, and then finish it off, plus 5. Okay, pause the video, complete it, and then come back and check to see if you're correct. Okay, distribute 4 times t squared, 4 times negative t, add a 5. Look to see if there are any like terms you can combine. There are not. So here's your final answer. This is h of g of t. which is not going to be the same as g of h of t. Now that is composition of functions. What if we were to evaluate a composition? Well, there are a couple ways to do this. You can rewrite the composition and input g of a into function f, which would be g of a, which would be this quantity, in for every place where I see an a in the other function. So I would have a plus 1 squared plus a plus 1 and I can evaluate that, simplify it, and then evaluate it for when a is 7. Or I can evaluate g of a when a is 7. 7 plus 1 is 8. And take that value and input it into function f and evaluate a when 8 is a. Sorry, evaluate f of a when 8 is a. 8 squared is 64. Plus 8 is 72. So f of g of 7 equals 72. Same thing, except 3 is going to be my input for function f. I input 3 and evaluate it, so I have 3 squared plus 3 times 3. That gives me 9 plus 9 equals 18. Now I've evaluated f of a for when a is 3. That f of 3 is input for g of a. Now I have to evaluate g of 18. Two times 18 is 36. Plus 1 equals 37. So g of f of 3 equals 37.